Hey guys, I wanted to show you a quick example of what I've been working on over the last day, I suppose. Yesterday and I guess all of this week I was having some trouble building some contracts and was running into a bunch of different issues. And the problem with working on contracts, especially when you use a real Ethereum client, is that the feedback loop for whether or not what you're writing, the feedback loop is very long. So you have to write some code, push the contract to the network, wait for the contract to be processed, maybe wait a couple blocks, and then send a transaction that alters state, wait for that to be processed, wait a couple blocks, and then maybe you make a call that checks the state to ensure that the state was set correctly. That could be that process could be a way of checking to make sure your code is correct, and it takes a long time because you spend a lot of time waiting for the mining process. So what I wanted is an RPC client that really I didn't have to wait for that process. I wanted everything that a normal Ethereum client did, except for all the networking and except for the mining. If we could strip those portions out, then we can have something that could be good for development and good for automated testing because you get instant feedback. So what I was tipped off to is something that Stefan George started working on, and he had created a wrapper, an RPC wrapper around the Pythereum client, and the Pythereum client has a tester.py file that basically does most of the work for us, that mimics the Ethereum virtual machine, takes out all networking, all mining, etc. So what I did is I took his script and altered it, and what we have is a basic Ethereum client, basic RPC client, that allows us to run these automated tests. So I want to give you an example of what I mean, because that's probably the best way to describe it. So if you look at this contract that I have, the main thing here is the App Store. Now you'll notice that I have this thing called set app factory. I'm trying to make my contract modular, but that doesn't really matter for this example here. All you need to know is that it takes this function here, set app factory, takes a factory address. It uses the factory interface to just kind of convert that, at least code-wise. But it takes that address and stores that address, and that is all that matters. And so to make sure that this piece of code works, it should work, but to make sure that it does, you can write a test for that. And what I've done is, if you take a look at appstore.coffee over here, this is a test built in Mocha using the Chai assertion library, and this contract function here is just an extension of Mocha's describe method. I've extended it to make it preload my contracts and talk to the TestRPC client to reset state so that the test runs at a clean state. Anyway, so what we have is we have the App Store contract. We're using Web3 to use the contract abstractions. So we have the App Store contract, the App Factory contract, which I didn't show you, but it doesn't really matter. Just know that the App Factory has an address. And then we use Web3 like it's supposed to be used. So first we send the transaction at the sending in the address of the App Factory, throw any errors if it exists, and then we make a call just right after we send that transaction to see if the address that we have within our contract, App Factory, matches what we expect. And this is really cool because there's no waiting for mining. previously, between these two steps, where you send the transaction and you make this call to see if the data was persisted, you'd have to wait and mine a couple blocks. Here we don't have to do that, and the test RPC takes care of that completely. So to give you an example, I'm gonna go over here. Already have some output here, but it's the exact same output. So I'm going to run npm test. This is going to run Mocha. It's going to run the test. Now, great, we have a test. We have something telling you, something giving you a green check mark that shows you that it works. But I mean, you shouldn't believe that, at face value. Just so you guys understand what's actually going on, let's go ahead and change the contract. So if we go to App Store, and here, this is, I wouldn't make the code this way normally, but for this example, instead of setting the address that's passed in, we're just going to set the address of message.sender. So what we should expect then is for this test to fail, because we're sending in one address, but we're going to get back a completely different address. And so if we run the test, that's exactly what happens. Now you'll notice that all I did was I changed the contract, and all that code that I have behind me compiled the contract, pushed it to the network. You can't see me quoting with my hands, but the network, that would be the TestRPC's internal chain that it holds. So it pushes it to the network and then runs that test against the network, first sending the transaction to set the app factory, and then making a call to get the data that's stored in there. And so, I mean, if you should notice that this becomes very powerful, because you don't have to wait a long time to know whether or not your contracts are working as you expect. And contracts being code that are hard to interact with as humans, this becomes something super valuable, because you can write tests to interact much more quickly than you can. So regardless, I hope it's helpful. Let me know if you guys have any questions. There's a lot of bootstrapping code. For instance, contract helper. For me, it sets the Web3 provider, then it resets the EVM, like I told you about, and then it compiles the contracts, and then sends that all to Web3. So there's a lot of bootstrapping code, which if you're not using a Node project, you'd have to write yourself. But this should be easy to do. So I'd love to hear your guys' thoughts. What I'm going to do is I'm going to go change this back, and you'll notice that it's one simple change, and it passes again. So cheers. Thanks a lot, guys.